Hi, my name is Jessica Rogers, and I'm the director of the Marshall W. Allworth Planetarium at UMD campus. And in this video, we are going to explore our solar system. And as we do, we are going to make our own model, pocket solar system, that's really going to highlight the distances between the planets. So in order to make our pocket solar system model, we're going to need a few things. First, you are going to need a long strip of paper. Now, if you don't have this, you can easily make one by grabbing a piece of computer paper or notebook paper like this. And all you need to do is fold it in half and then fold it in half again so that you have 4 long segments that you can cut out like this and then tape them end to end so you end up with your long strip of paper. You will also need a pencil or something to write with, and you might also want some stickers or some markers or crayons to color in the planets themselves. So to make our pocket solar system, the first thing we need to do is define what the 2 ends of our paper represent. Now, one end is going to be what sits at the very center of our solar system, and that, of course, is the sun. And so on one end of the paper, you can just write sun. Sitting at the center of our solar system is our sun. Our sun is a star, just like the stars we see up at night. It's just, of course, a lot closer to us, and so it appears a lot bigger and brighter than all of the other stars in the sky. But since it is a star, that means that it is a big ball of hot gas that at the center is undergoing what we call nuclear fusion, where hydrogen atoms are being running into each other and sticking together and forming helium atoms. And that's what creates the light and the heat and the energy that we see coming from the sun. Our sun is quite large. It would fit about 109 Earths across it. We also see that it is not perfectly smooth. There are these dark spots on the sun that we call sunspots. Very clever name. These areas look darker because they're a little bit cooler than the rest of the sun. Now, not very cool. We're still talking like 7,000 degrees Fahrenheit instead of 10,000, but the fact that they are a little bit cooler than the rest of the surface makes them look darker. They're also a lot bigger than you might expect because the sun is a lot bigger than we tend to think of it. So one of these little sunspots, this one right here, that little sunspot is actually about the size of the Earth. Yeah, quite big. Then we can also see coming off the edge of the sun these loops of gas sticking out. These are called prominences, and they're literally loops of gas that are coming off the sun that are following the magnetic field that surrounds the sun. And those loops of gas can become solar flares. What happens is if that loop stretches out too far, it'll actually snap, very much like if you stretch a rubber band too far. And when it snaps, it flings all of that gas out into space and becomes a solar flare. That is our sun. At the other end of our paper, that represents the outer edge of our solar system. And that is a region we call the Kuiper Belt. And so on the other end of your paper, you can write Kuiper Belt. Sitting out past the planet Neptune lies a region we call the Kuiper Belt. This is an area full of icy debris left over from the formation of the planets, and it's actually one of the sources for the icy comets that we see sometimes flying nearby the sun, giving us those spectacular views. Now, also residing in the Kuiper Belt is the former planet, now dwarf planet, known as Pluto. So when Pluto was first discovered back in the 1920s, it was the only thing known out in this region of the solar system, and so it was called a planet. But then in the early 2000s, we started finding lots and lots of other things like it. As you saw, there are a lot of things in this area. And so astronomers decided, instead of calling all of these things planets and having dozens and dozens of planets, that we would come up with a new category for Pluto and the things like Pluto. And those became known as dwarf planets. And 4 of the 5 dwarf planets reside in the Kuiper Belt. Those are Pluto, of course. There's also Haumea, Eris, and Makemake. The 5th dwarf planet, Ceres, is actually in the Asteroid Belt, and we'll see that in a little bit. Now that we have our 2 ends defined, let's make our first fold. So what we're going to do is take the 2 ends of our paper and line them up to meet so that we fold our strip of paper in half and make a nice little crease there. And so now let's figure out what's going to go halfway between the Sun and the Kuiper Belt. Well, if you guessed the planet Uranus, you would be correct. So on that fold halfway between the Sun and the Kuiper Belt, we can either take one of our stickers or take our markers and put our planet Uranus there, just like that. The 7th planet from the Sun is the planet Uranus, the planet with the funny name, although that wasn't always its name. When it was first discovered, this planet was named George. Yep, Georgium Sidus to be exact. So the astronomer William Herschel is the man who discovered the planet Uranus, and since he was an Englishman, he knew that if he named it after the King of England, that would make the king happy, so he named it Georgium Sidus after King George. And of course, the king was very happy and gave him a lot of money for it. But the other astronomers who didn't serve the English king were not happy about this. So they decided, after many years of debate, to rename the planet to Uranus. And they chose this name because Uranus is one of the Greek gods, and that fits the theme of the planets being named after Greek and Roman gods. Now, we don't see a whole lot of features on the planet. We do see this really pretty bluish green color, and that actually comes from methane gas in the atmosphere. Methane is really good at absorbing red light, but reflects blue and green light, and so those are the colors that make it back to our eyes. What is strange about Uranus, and if I turn on its moon here, moon orbits, we can see that the moons orbit perpendicular to Uranus's orbit around the sun. That tells us the planet itself is kind of lying on its side and rolling around the sun. And we aren't quite sure why this planet is on its side. But one of the likely scenarios is that it literally just got hit by something really big and that knocked it over. All right, let's make our next fold. So let's fold our paper in half, just like we did the first time. And then we're going to fold it in half again. So we're going to bring the fold that is the planet Uranus up to meet the other end and make a crease. So now we should have a fold in between the Sun and the planet Uranus, and a fold in between the planet Uranus and our Kuiper Belt. So we now have 2 more lines and 2 more planets to put on. Well, let's start with in between Uranus and the Kuiper Belt. The planet that sits there is the planet Neptune. So we will take either our sticker or our pencil or marker to make our planet Neptune, sitting in between the planet Uranus and our Kuiper Belt, just like that. The 8th planet from the Sun is the planet Neptune. with this gorgeous blue color that comes from methane in its atmosphere, much like the planet Uranus. We do see some features here, though. We see some high, kind of whitish clouds. Those are methane ice crystal clouds. And then we also see several moons around the planet as well. Now, on the other side, in between Uranus and our sun, sits the planet Saturn. So we will again put our sticker or draw our circle and label the planet Saturn, which sits right there, halfway in between the planet Uranus and the sun. The sixth planet from the sun is the planet Saturn, most known for its beautiful ring system. Although it's not the only planet to have rings, Jupiter, Saturn, Uranus, and Neptune all have rings. It's just Saturn's are the biggest and the brightest, and so they're the easiest to see from telescopes here on Earth, so they were the first found and the most well known. Now, even though these rings may look like they're solid, they're actually made up of millions of particles of ice. And these can range anywhere from the size of a grain of sand all the way up to chunks the size of a house. Now, a lot of these particles are probably pieces of the moons around Saturn. Saturn has 82 moons around it. And as those moons get hit, little pieces are broken off, and those probably fall into orbit around Jupiter, creating these rings. But the reason that Saturn's, but the reason Saturn's rings we think are so much bigger and brighter than the other outer planets is we think due to a temporary enhancement. A comet probably got a little bit too close to Saturn and got ripped apart. And all of that icy debris is now currently sitting around Saturn in these rings that we see. Now let's make our next fold. What we're going to do is we're going to take the sun and fold it up to meet the planet Saturn, and crease right there so that we are now making a fold halfway in between Saturn and our sun. And sitting there, halfway in between Saturn and our sun, is the planet Jupiter. So let's go ahead and label our planet Jupiter. Just like that. The fifth planet from the sun and the largest planet in our solar system is the planet Jupiter. Jupiter would fit about 10 Earths across it, so quite a large planet. It's also about 300 times the mass of the Earth. But even though it's so big and so massive, it's not made of rocks and metals like the Earth is. It's actually primarily made of hydrogen. Now, a lot of people hear Jupiter and the other outer planets nicknamed as gas giants, but that's actually a misnomer. They're not primarily gas. They're actually primarily liquid, so it'd be more accurate to call them liquid giants. And so while the very outer layer is hydrogen gas, once you get past that very outside, the temperatures and pressures squeeze that gas into liquid hydrogen. And so they are more apt to be called liquid giants. One of Jupiter's most famous features is this great red spot, which is known as the Great Red Spot. This is a hurricane that kind of similar to hurricanes here on Earth, except a lot more extreme. This hurricane could fit 3 Earths inside of it, and it's been going on for over 350 years. We're not quite sure why it's lasted for so long, though. That's still an active area of research. Jupiter also has a lot of moons, 79 to be exact. Now, most of these are things like asteroids or comets that have been captured by Jupiter's gravity, but some of them we think did actually form around Jupiter in kind of like a little mini solar system fashion. Now on to our next fold. We're going to do something very similar. We're going to take the sun and we are going to fold it up to meet the planet Jupiter so that we are creating a fold halfway in between Jupiter and the sun. Now what sits there? It's actually not a planet. Sitting in between Jupiter and the sun is a region that we call the asteroid belt. And so we can go ahead and write asteroid belt on that fold. Sitting in between Mars and Jupiter is a region that we call the asteroid belt. Within it are thousands and thousands of pieces of rock that are left over from the formation of the planets. And we of course call these the asteroids. Now, these asteroids come in a range of sizes and shapes. The largest asteroid is named Ceres. It was the first one discovered and is the only asteroid that is large enough to actually be spherical in shape, as we see here. Most of the asteroids, though, are irregular in shape, very lumpy, and much smaller. So here's a good example. This is the asteroid Ida. And Ida actually has its own little moon named Dactyl. So asteroids can have moons as well. Now for our next fold, we're going to do a very similar one again. We're going to take the sun and we are going to fold it up to meet the asteroid belt so that we are creating a fold right in between the asteroid belt and our sun. And sitting there is the planet Mars. So let's go ahead and put our sticker or draw our circle and label the planet Mars. Mars is the fourth planet from the Sun and is often known as the red planet because of its red color. That red color that we see comes from rust that's covering the surface. Mars is actually only about half the size of the Earth. It's a lot smaller than people tend to think. But Mars does have some things that look familiar to us here on Earth. Around the North and South Pole, we can see polar ice caps. Now, a lot of the ice in these ice caps is water ice, but there's also a lot of frozen carbon dioxide, which we call dry ice, there as well. On Mars, we also see a lot of volcanoes, the largest of which we can see here is known as Olympus Mons. It's not only the largest volcano on Mars, it's actually the largest volcano in the entire solar system. This volcano is so big that if you were to set it on Earth, it would cover up the entire state of Arizona, and it's 3 times taller than the tallest mountain on Earth. Now, even though the volcano is no longer active, at least we haven't seen it be active, we know that it had to have been very active in the past in order for it to grow as large as it has. We also see a few other volcanoes nearby, and there are some other smaller volcanoes scattered all over Mars, all of which also appear to be dormant. But the other really cool feature that we see is this big canyon called Valles Marineris. It's a lot like the Grand Canyon, but honestly grander. This canyon would stretch across the entire United States, and at some places is 4 times deeper than the Grand Canyon. So definitely worthy of the name grandest canyon in the solar system. Mars also has 2 moons. They are named Phobos and Deimos. Although they are a lot different than our moon, they are more of what we would call lumpy space potatoes. They're little lumps of rock that are orbiting around Mars. And given their similarity to asteroids, we actually do think that Phobos and Deimos are captured asteroids. Now, you'll notice here we have very little space left, and we still have 3 planets to fit in there. For our last set of folds, we're going to do two folds at once. First we're going to do is take the sun and fold it up to meet the planet Mars. And then we're going to take the edge that we just created and fold that up to meet the planet Mars. So we basically took the end and folded it to Mars, and then we took that little folded section and folded it in half again. And that has now created three folds in between Mars and the Sun. Sitting at the fold closest to Mars is our home planet, the planet Earth. So let's go ahead and label that. And you may have to start staggering your labels and your stickers because these planets are very close together. The third planet from the Sun is, of course, the one that we know best. It is our home, the planet Earth. Currently the only world in our solar system, planet or otherwise, that has liquid surface water. And is, of course, the only world that we know of so far that has life. And that makes Earth pretty special. Now, one of the reasons we think that Earth is able to have so much liquid surface water is because we are just the right distance away from the sun for the temperatures on Earth to allow water to be in a liquid state rather than frozen or as a water vapor, as a gas. Earth also has a moon, which we just call the moon. Our moon is a big ball of rock, about 1/4 the size of the Earth. And we see that it is covered in craters because there is no process to erase those craters once they form. There's no erosion, plate tectonics, anything like that. The side we are currently seeing is a side that you probably are not familiar with because this is the side of the moon that always faces away from us. And so we don't actually see this from here on Earth. This is the side of the moon that we are more familiar with, and we can see these dark patches. These dark patches are known as the lunar maria. Maria is Latin for sea, like a body of water, because we thought that at one time this might have been bodies of water. We now know that this is just a darker colored rock that is the result of lava flows that happened about 3 billion years ago. We don't have lava flows anymore on the moon. It's cooled down. There's no more molten rock under the surface. So these date back from a time when the moon was much younger and much hotter than it currently is today. Now the next line is the planet Venus. And so we have Mars, Earth, and Venus. The second planet from the Sun is the planet Venus. Venus is actually very similar in size to the Earth, about 98% the size of our Earth. We also see that it has a lot of clouds. In fact, it has so many clouds that we can't see through them down to the surface. And that led a lot of people early on to believe that maybe Venus is a lot like the Earth, and it ended up being nicknamed Earth's twin. But we learned that that was incorrect in the 1960s when we developed radar technology that allow us to peer through those clouds. And what we saw was a planet that definitely does not look like the Earth. We see no water, no vegetation. All we see is a very, very hot land. Um, Venus is actually hotter than the planet Mercury, the closest planet to the Sun, with temperatures reaching over 800 degrees Fahrenheit. And that comes back to Venus and those really thick cloud layers. Those clouds act like a thick blanket that trap heat and allow the temperature to get very, very hot and stay hot. It stays that temperature all the time, day and night. There is no kind of fluctuation between day and night or even seasons. It's that hot all the time. And then our very last line is the closest planet to the sun, the planet Mercury. And so we can go ahead and put our sticker and label Mercury. The closest planet to our sun is the planet Mercury. Mercury is pretty small. It's about 1/3 the size of the Earth. And we see it doesn't look too terribly interesting. It's a big ball of rock that's covered in craters. And this is because it has no atmosphere, it has no erosion, it has no volcanoes or plate tectonics. So the only thing that's happened over the past 4.5 billion years since the planet's formed is it's been hit again and again and again by space debris like asteroids and comets. And each time something hits, it leaves behind a crater. And since there's no processes to erase those craters like erosion, they just keep adding. And we end up with this little tiny planet absolutely covered in craters. Since Mercury is the closest planet to the sun, it of course gets very hot in the daytime, temperatures exceeding 500 degrees Fahrenheit. But at night, it actually can drop down to -200 degrees Fahrenheit. And that again comes back to Mercury not having an atmosphere. Atmospheres act like blankets, they trap heat. Without that, the nighttime gets very, very, very cold, as we see. And with that, we have created our pocket solar system. So one of the things you should notice right away is just how close together the four inner planets are and how spread apart the outer planets are. Now, another thing to note here, these stickers that we used are not to scale. So the actual planets are much, 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 much smaller than this. If we were to try and do distance and size of the planet to scale, we would either need teeny tiny little stickers, or we'd need to turn our model into a much bigger model. But there you go. You now have a solar system that you can fold up and put in your pockets.